wish I had some sort of a horn I could blow or something like that, because it's time to celebrate, because this week we're going to actually work on something fun. So this week we're going to be working on gaming, not video games. We're not going to be building video games. The knowledge of programming that is required is probably a bit beyond this class, but we can design some good text-based games, and we also can design some desktop applications. That'll be next week. But this week, we're going to focus on text-based gaming. Now, let's take a look at this PowerPoint I made to take us through how to make a decent game that's both compelling and exciting step by step. Let's take a look. All right, this PowerPoint is called Gaming Games of Chance, and let's take a look at the next slide if we can. How the heck do I navigate to the next slide? Okay, here we go. And the gaming requirements, what are the requirements to create a game on Python? We have to have random events, so we have to have things that can or cannot happen. So there has to be some change of situation, like for example playing Grand Theft Auto. If the people walk exactly the same way in the same familiar patterns, it's not fun. So there has to be some randomized element to it to change the environment, and the outcomes must be based on those events. So in other words, if you make a choice to maybe bet on a number and it doesn't come up, there has to be some effect, like you lose a balance or you lose a turn or something, and then of course usually you bet money on it. Of course, in this particular case, we will be betting fake money, and then in order to proceed, we need to at least review basic data structures. Here's an example of a list. We know it is a list because it has these straight brackets, and as you know, a list is any sequence of items, and they could really be anything. Here is an integer, here is a float value, here is a string. You can even have another list. When you have a list inside of a list, or two lists inside of one list, we call that a multi-dimensional list, or a list of lists, or you can call that a matrix, actually. However, there's no list inside of a list here. This is just an integer. Here's a string, another string, here's a float, and here is another string. However, we recall a list is, I'm going to say, a list, each item in the list resolves to an offset. You recall that. So going back to this list, if we go to Linux right here, my list equals 1245 Gold Lakeside Park. The Lakeside Park is actually the name of a famous Rush song, and actually there's probably so many parks here and in the United States and Canada called Lakeside Park. There's probably so many streets in US and also Canada named Lakeside too. But anyways, I just created this little list right here, and I just wanted to indicate that if we say my list of the third index, that's going to be 0, 1, 2, 3. So we're going to wind up with Lakeside Park. And because lists also support item assignment, we could say M3 equals maybe another one of my favorite Rush songs, Tom Sawyer. And we can actually print my list again. Print my list. And let me see. Oh, forgot a letter right here. My list. And now we have 1245 Gold and Tom Sawyer instead of Lakeside Park. Okay, so I just wanted to review the fact that lists do support item assignment, and I just wanted to review some basic aspects of the list. But yet, we can use a list to create a text game or a game of chance using a randomized number. Let's take a look. Next up, as the Joker from The Dark Knight, Batman The Dark Knight, said in that famous scene where he blows up the hospital, he tells Two-Face, or the character that would soon become Two-Face, he said, let's bring a little chaos into the situation. So how can we present the potential game player or the user with random situations? And there's actually the random module that we can import in Python, and we can say x equals random.randrange of 5, and we could say my list 1245 Gold Lakeside Park, and you recall that is from the prior slide, and we can say, instead of saying my list of the third offset, which is Lakeside Park, we could actually create a variable x equals random.range5, and that would generate a random number from 0 through 4, strangely, because the 5 is the outer limits, so you don't include 5. It's just everything prior to 5, including 0, so that's 0 through 4. And of course, as luck would have it, it chose by random the fourth choice, which is 1, 0, 1, 2, which is the third choice, and it's 0, 1, 2, 3. Actually, that should be 4, because there's only 4 choices, 1, 2, 3, 4. But remember, that's 4, so that would be 0, 1, 2, 3. So let me go ahead and change that really quickly. All right, let's take a look at the improvement, not necessarily improvement, but I did change the rand range to its rightful place, rand range 4. All right, I did make that quick fix. I changed this 5 to a 4 because it only makes sense. There are only 4 items in here, so the rand range should only be 4, but technically it's to 3 because it's the offset starts at 0. So this is 0, 1, 2, 3. So if x is equal to a random number between 0 and 3, obviously the x in this particular case equal to 0 because what comes is 12. The same thing here, it equals 0 again. This time it's gold, so this would have been 2. The second position, 0, 1, 2, and that is gold. Now, there is a slight, I guess you could say, improvement in the syntax, because what I did here was I just printed, instead of saying print x, where x is equal to a random.rand range, I substituted random.rand range for x, and for the length value, I said whatever the length of the list is the range of the randomized number, because in this particular case, the list is 4 elements long, 1, 2, 3, 4. However, in terms of indexing, it's the amount minus 1, because it's in index-wise, it starts at 0. However, len doesn't take indexing into account. It just is the raw number, like the human form number. So the reason why we would just actually put in the literal len command right here is because this controls for the fact that we can create any list of any length, and we can have the user control how long the list is, and we can still call this command because it still applies, meaning we don't have to adjust the length of the list based on that particular instance. Anyways, this is just more of a, I guess you could say, generic call out for doing the same thing. So I want you to take a look at this and how it's constructed. So it's basically this, except for the number 4, we literally just have the len of my list right here. And instead of print my list x, and x is equal to random.rand range, the length, we just put this whole entire thing in the curly, in the straight brackets right here. So take a look at that, and let's go ahead and do an example. In this particular case, we are going to create a basic text game with lists. So the first step is we are going to create a user-controlled list. What that means is that the prompt will say, until you do something, until a particular condition is fulfilled, continue to fill this list. So the user determines how many items and what items are in the collection. The next step is that the user, or let's say another user, randomly selects an item from the list. So a good model is maybe have an item in the list that is, you would get a reward for guessing, or you would get penalized for guessing. So for example, let's say we had a treasure chest, and inside the treasure chest, there's various items like food and arrows and gold, but maybe there's an item that is would end the game if you randomly chose it. Let's say a bomb or something like that. and we'll explore that next. And then we have to simulate betting. So the reason why people want to play any type of game is if they get some benefit, whether it's bragging rights, whether through a victory, or whether it's money. So we will simulate that next. So let's take a look at what we have here. If you could give me a second. Here we go. And let me make sure we're in focus. Step one is, well, actually, even before our steps, we have to import. We know we're going to utilize the random module at some point. So we went ahead and we imported random first. So step one, fill out the list and collection. So we create an empty list. We call it treasure chest, and it's an empty list. It's a list. We know it's a list because it's an open and close brackets. And then we use this as a reference variable. Item equals an empty string. And then we can say, and there's different ways of doing this. What I did was I said while true. So in other words, while the condition is true, if the item is not equal to latch, and latch is the reference variable that we will use to end this while loop. So if item does not equal latch, and just so you know, that is a exclamation point and an equal sign, and for some reason Kali combines them. Kali, the Vim program in Kali combines them. I don't know why, but it does. Maybe it does that also in idle. I don't know, but that is just and let me just put it right here as a comment. So that is just exclamation point and equals. It did it again. I don't, it just does that. So if most of you are on Windows, maybe you're on Notepad++ or something, Notepad++ probably won't do that, so just be aware. It's just exclamation point and equals, so that means not equals. Anyways, so as long as the item does not equal the word latch, it's going to continually ask us to input an item into the chest, and then if we follow the code block here, it simply proceeds to the next code item. It's going to append that particular item into treasure chest. So append is a method of list, and then we have else break. So in other words, if item doesn't equal latch, it's going to input each item into the chest. However, you can fulfill the condition of the while loop by saying item equals latch, and that goes to the next else, and then break, and it breaks out of the while loop, and then it says you filled it up. Here it is, and it gives you the treasure chest. So let's go ahead and run this as is. Now notice I do :W and then exclamation point to get out of here. Did I say? Okay, never mind. Okay, so we got out of there, and let's go ahead and run this. Enter item into the chest. So we have, we'll say tree, arrow, gold, bomb, food, bedspread, and we'll say latch to end this. Okay, so you filled it up here. Here it is: tree, arrow, gold, bomb, bedspread, and then latch. So we have done that so far. Let's look at step one. And step one, we fill out the list and collection again, and this is just a review. If item does not equal the word latch, and that will be, what that means is that when we want to end the inputting of the list, meaning we want to fulfill the while loop condition, we actually put in latch, and that breaks out of this if block and goes into the next block, which is the else, which gives us the keyword break. The keyword break actually breaks out of the while loop, and then it'll say you filled it up, and here is the treasure chest. Now step two is using random to select from the list that we created and actually make the game. And let me move this over a little bit. Let me do it this way. Okay, just to fit things in. And we have input, press enter to select type. Now this is what we call the raw input trick. Now the new line gives us a new line just for formatting, and this is the user choice that will happen. This is, if you go back to the other PowerPoint slide regarding this right here and right there, my list is equal to 1245 gold and then Lakeside Park, and random range of 4 gives us the value of X, and that's going to give us the randomized index from that list. However, However, we can we told you about utilizing this little shortcut right here. So instead of doing this, we go from this to this, having instead of print x and x is equal to random range, we can do MIL with the index of the rand range here, and the upper point, or shall I say the ceiling value, is the length of my list. This gives us flexibility in that we don't have to have a predefined length. The user shall define the length. So it's the same thing here. The user choice is equal to treasure chest random.rand range len of treasure chest. And so let's take a look at what this entire syntax looks like. All right, let's take a look at what is happening so far in our game. We have import random, and that really is something that we don't really need until step 2, but we want to always begin with importing the modules that we want. So step 1, filling out the list. Creating the list. So this creates the empty list. For reference purposes, this is the empty item variable, and that's an empty string. And we have while true, which means the while loop will run the inside block until you tell it not to. And we say if the item does not equal latch, then we will enter items into the treasure chest. So that is the append method of each item into this empty treasure chest. And when we want to stop doing it, we will just say item input item equals latch, and it breaks out of the while loop. And then to signify that, it then executes this next statement. You filled it up, here it is. And this is the special formatting type of print statement, and it says you filled it up, here it is, and this is the treasure chest. Now step 2 is we use the random module to select or choose an item from the list. So this statement right here allows us to choose a randomized item from the list based on the index 0 to the end, or 1 to the end of the length, because this is the len treasure chest. And then it says user selection is your user choice. Now here is the game itself, because step 2b is make the game. The game itself is that if the user choice is gold, then we win. So the outcome is an empty string, and the outcome is win if the user choice is gold. Now if the user choice is bomb, outcome is lose. And then here we present the outcome. We print the outcome. Now step 3 is to simulate the betting. So let's go ahead and let's get out of here and let's run the game. Enter item into the chest. So we'll say gold. We don't have to say it right now, but we can say arrows, food, and we can say, blanket, and then maybe kindling to start up a fire if we wanted to, and then bomb. We have to have that in there, and let's just say fish for the heck of it, and let's just say money. And now let's end this. We'll say latch, and that ends it. And then it says press enter, select item. I'm going to press enter, and it says your selection food, and it's a push. So because my randomized selection was not gold or bomb, I don't win or lose. We could try it again, and we can just enter random stuff into the list, and then we'll say gold, and then bomb, and latch, and press enter. And then because it just selected this randomized number, it said select push. Let's go ahead and almost make sure. I'm going to say bomb and then latch. That almost assures us that we're going to lose. And guess what? My selection is bomb, and in fact we lose. Okay, so that's the game so far. So now what we want to do is we want to make it so that step 3 is to simulate some sort of compensation like money. So that's what we will do in the next and final step to this game. All right, let's take a look at what is happening so far in our game. We have import random, and that really is something that we don't really need until step 2, but we want to always begin with importing the modules that we want. So step 1, filling out the list. Creating the list. So this creates the empty list. For reference purposes, this is the empty item variable, and that's an empty string. And we have while true, which means the while loop will run run the inside block until you tell it not to. And we say if the item does not equal latch, then we will enter items into the chest, into the treasure chest. So that is the append method of each item into this empty treasure chest. And when we want to stop doing it, we will just say item, input item equals latch, and it breaks out of the while loop. And then to signify that, it then executes this next statement. You filled it up, here it is. And this is the special formatting type of print statement. And it says you filled it up, here it is, and this is the treasure chest. Now, step 2 is we use the random module to select or choose an item from the list. So this statement right here allows us to choose a randomized item from the list based on the index 0 to the end, or 1 to the end of the length, because this is the len treasure chest. And then it says user selection is your user choice. Now, here is the game itself, because step 2b is make the game. The game itself is that if the user choice is gold, then we win. So the outcome is an empty string, and the outcome is win if the user choice is gold. Now, if the user choice is bomb, outcome is lose. And then here we present the outcome. We print the outcome. Now, step 3 is to simulate the betting. So let's go ahead and let's get out of here and let's run the game. Enter item into the chest. So we'll say gold. We don't have to say it right now, but we can say arrows, food, and we can say, blanket, and then maybe kindling to start up a fire if we wanted to, and then bomb. We have to have that in there, and let's just say fish for the heck of it, and let's just say money. And now let's end this. We'll say latch, and that ends it. And then it says press enter, select item. I'm going to press enter, and it says your selection food, and it's a push. So because my randomized selection was not gold or bomb, I don't win or lose. We could try it again, and we can just enter random stuff into the list, and then we'll say gold, and then bomb, and latch, and press enter. And then because it just selected this randomized number, it said select push. Let's go ahead and almost make sure. I'm going to say bomb and then latch. That almost assures us that we're going to lose. And guess what? My selection is bomb, and in fact, we lose. Okay, so that's the game so far. So now what we want to do is we want to make it so that step 3 is to simulate some sort of compensation, like money. So that's what we will do in the next and final step to this game. All right, so this is that next program, the next iteration, I guess. We have the treasure hunt as an entire function. So I put everything we've done in here inside of a function. So I took away the comments to centralize things a little bit more, but everything pretty much is the same. So in other words, if you actually if you've been following me along in creating your Python files in Notepad or Notepad++ or something, and then running them via your terminal, then this would be the next iteration. So you just tuck everything neatly into a function. So just scooch everything over to the right by pressing either the tab button appropriately, or the spacebar 4 times appropriately. So this would be, so to go from this to this, you would take this, you would create the defined function treasure hunt, and then you'd scooch this over 4 times with a spacebar, scooch this over 4 times, that time 4 times, and for this, you would scooch it over 4 times, but for this, you would have to scooch it over 8 times on the spacebar, or if you're using the tab, you just scooch this over once, and then here twice for this one, because you scooch it over once and then again, so that's 2 times you press the tab. So you wind up with something like this, and then you can run it just by typing treasure hunt and then open and close the parentheses, because of course treasure hunt is a function. Now once you do that, next change that you can make is you can, let me bring this up a little bit. You know what, let me bring this, I have to bring the whole thing up a little bit. There we go, so you can see what's down here. What I did here was I replaced outcome equals win, and then right before we go to the else if or elif block, or else if block, we actually put a return statement. So the return value of treasure hunt in the case of the user selecting gold is win. Now if the user happens to select bomb, he loses, and if he selects anything else besides gold and bomb, it's a push. And here we say print result of the outcome outcome. Now, final game part 2 is to integrate the actual banking or financial or compensation. So while bank balance is greater than 0, okay, we can actually ask the user, do you want to play treasure hunt? $50 a try, type yes or no, or Y or N. So if gameplay equals Y, then play treasure hunt, and play equals treasure hunt. So that means it's going to instantiate the treasure hunt function, meaning that it's actually going to execute it, and it's going to capture that execution in this play variable. Now, the game result will be the result of the return value, whether it's win or lose, and then it's going to print it. Now, if play equals win, or if the logical value of win is equivalent to play, or play is equivalent to win, then it increases your bank balance by 50, else it removes it. So in other words, you win $50 if you win, so the only way to win is if you choose gold, and if you get bomb or basically anything other than gold, you lose. You actually lose $50. That's the way casinos work in generally. Now, if gameplay, to break out of this while loop, if you say anything other than Y that you want to play breaks out of the while loop, and then it says thank you for playing, your balance is bank balance. So this is the program itself. Let me go ahead and change the perspective. This is the program in general. We start off with import random, and we have our function right here for treasure hunt, and this really is the dividing line between the function, and let me just do this. This is the dividing line between the function right here and actually executing the function on this part of the code. So this is the function execution. So we define the bank balance, and while bank balance is greater than 0, then we enact and execute the function in a way that really defines our vision of how this program should play out. So we want it to say, we want to reward the user for winning, meaning obtaining gold, and we also want the reward is to add 50 to his bank balance, and the, I guess you could say, cost of not winning is to remove 50. And then at the when the while loop breaks, it then the next command in this coding executes. Thank you for playing, and your bank balance is, and then whatever your bank balance is. So let's go ahead and quit this, and let's run the program. So care to play treasure hunt? $50 a try. Let's say no to test it out, just to make sure it does end like it should. So we say no, and the bank balance is 100. It doesn't change. However, let's play it, and let's type Y for let's play. Enter item into the chest. So that's blanket, maybe some survival items, cooler, food, and then here's gold, and let's say silver, arrows, bow, bullets, and finally bomb, because that is a game part of the game, and let's say latch, and you filled it up. Here it is. Type enter to select item. You know what? I shouldn't have type latch when finished. Okay, select your item. Your selection is arrows. It's a push, and so because I didn't get gold, the bank balance goes down. Type Y for yes. Enter item. Let's just enter a bunch of stuff here, and let's say gold, bomb, latch, enter. Okay, so balance is 0. Thank you for playing. I want to fix this because it's kind of like annoying me. So let me go here. Let me go into here, and I shouldn't have, that doesn't make sense. I have type latch when finished, and enter item in the chest. I should have it here. Type latch when finished, and I want to have a new line come up there. So this makes more sense. So let me just right quit and let me run it. Okay, care to play treasure hunt? $50 a try. Let's say no, see what happens, and I just want to make sure that does happen as we suspect, but let's press Y for yes, and then it says enter item in a chest, type latch when finished. So let's say tree, trimmer, blanket, gold, latch, let's say bomb, latch to finish, and press enter, select item, and your game result is tree trimmer, and that's a push, and balance is 50. We want to play, and let's make sure that we have let's say for sure we win. So I'm only going to put in gold, and I'm going to put in latch. Oh, it chose latch. Let me just make sure. Let's really try to win. So gold latch. Okay, well, it's a push still. It chose latch. Let me try again. I'm going to say, no, I don't want to play again. And let's play once more, and I'm going to say gold latch. Yeah, oh my god, it chose latch again. What the heck? I want to play once more and enter item into chest. Gold latch. Oh my god, I'm like the unluckiest guy in the world. Yes, gold latch. All right, I won. Too bad I had to stack the deck in my favor. All right, so that is the game in a nutshell. I hope you enjoy the treasure hunt game. So in this week's assignment, I would probably make it so that, you know, I'd like you to improve the game somehow, and the assignment will tell you how.